Hi there, Mrs. Thompson here, and today we're going to go over electron configuration, part 1. We've already talked about atomic orbitals and how you draw an orbital diagram. So now we're going to go a little further into electron configuration. Alright, so last time we spoke about the off-bow principle and how electrons are filled in the lowest possible energy levels first. We call this their ground state. So it fills up according to those rules. Starting in the 1s orbital, then the 2s orbital, the 2p, 3s orbital, and then we move on to the 3p, skip 3d, and move into the 4s. Alright, so we drew orbital diagrams. Now what we need to be able to do is show what's going on inside of those orbitals. And so it's pretty much the same thing. This is the orbital diagram for oxygen. So we're just going to write the name of the orbital and how many electrons are in it. So this is the 1s orbital, and it has 2 electrons because it has 2 arrows. This is the 2s orbital, and it has 2 electrons in it. Okay, then I'm going to list the 2p orbitals. Those are all together, and there are 4 electrons in the 2p. So the ground state electron configuration is just the orbital diagram, but kind of shortened in a way. It's just telling you how many electrons are in there. Okay, we'll do this again. So I'm just going to count the number of electrons in each orbital. So in the 1s, right here, that's 2, 2s, 2. Notice we're separated by spaces. So these boxes are connected. So these are all going to go together. These are the 2p orbitals. So 6 electrons, 3s, 2, 3p, 6, 4s, 2 is this one, and then 3d, 10. So what element is this that has all of these electrons? We can figure out which element it is by counting up all of the electrons. So 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10. So all of them adds up to 18 electrons, and that is argon. Alright, so we're going to use the periodic table to figure out the electron configuration. And so to come up with this part right here. Alright, so you need to know the blocks on the periodic table. These first 2 columns are the S block. And that does include helium over here. It's part of the S block. It only has the S orbital when it's in the ground state. And then we have D block in the middle. Call these all the transition metal elements. And then we have the P block over here and the F block. Okay, those blocks correspond to that SPDF that we learned before, and their length corresponds to how many electrons you can put in those orbitals in total. So in the S, we can put 2 electrons. That's why the S block is 2 wide. In P, we can put 6 electrons. That's why there's 6 wide. D, 10, so this is 10 wide. F, 14, so this is 14 wide. Alright, I need you to color your periodic table. So I've already colored mine. That's a picture of mine. Didn't spend a lot of time coloring, so please don't try to spend a really long time coloring. You can either use crayons, highlighters, whatever you have at home. But you need all of these 4 different blocks in 4 different colors. So remember that the S block in mine is this column, plus helium. So be careful, this is not part of the P block. And then I just labeled it S right here. And then we have the P block. It's these 6. And I went ahead and shaded in the ones that we have that are blank. The D block goes from here all the way to here. And we're going to write something special for the D block. We're going to write D is N minus 1, and I'll tell you why in a little bit. And then we have the F block right here all the way across. There it is. That is N minus 2, and I'll also tell you why that one is N minus 2. Okay, so just to clarify, remember that this is the S block, that is the P block, D block is behind by 1, and F block is behind by 2. So you should have those labels already. What is the N number? Well, the N number is the row number. That's the number of energy levels. And so I would like you to add this in. N is equal to, this is the row 1, row 2, row 3. This is the energy level that those electrons are in for that particular element. Now, if you notice, the number next to the orbital matches the row numbers for S and for P, but if you look in the fourth energy level, it does not match for D. It goes from being 4S to 3D instead of 4D. The reason for that is because as we gain an electron and as we change in atomic number, we gain an electron. It's where those electrons are overlapping in terms of how much energy it takes to put them in there. And so instead of going from 3p to 3d, it goes from 3p to 4s first, then back to 3d. And so for our D block, we're going to write that it's behind by 1. And then for our F block, it's actually behind by 2. These two segments are from row 6 and 7. You might want to label that. I just noticed it's not on there. So this is row 6. Came out of this portion of the periodic table. This is row 7. It's behind by 2 because if you notice down here it says 4F and then 5F. Alright, so this is what your periodic table would look like if the F block were inserted inside of the periodic table. We take it out because it doesn't fit. It would go on a really long piece of paper. So we take it out. Alright, so let's talk about each one of those pieces of the electron configuration. So if I have this, what does that mean, 1s1? Okay, so the 1 refers to the energy level that the electron is in. That's the N number, or the principal quantum number. The S tells us the sublevel, which we know as shapes, spherical, peanut, double peanut, and flower. And then the 1 in the exponent there is the number of electrons that are in that sublevel. Okay, in terms of reading that location on the periodic table, it works like this. A 1s1 would be, the 1 would be the first row of the periodic table, or whatever row it is, and then with the number in front, the coefficient. The S tells me it is in the S block. And the 1 tells me that it's in the first column of the S block. Okay, for this you're going to need your periodic table. We're going to find the electron configuration of sulfur. And so first we have to figure out where sulfur is at. It's atomic number 16, so that's where we need to get to. Our starting point is going to be at the very beginning. We're going to pretend this is like a board game. And so in a board game, you'd start at the very first step. So we would start at hydrogen, being that it's atomic number 1. And as we walk across the periodic table, we're going to keep track of where we've been. And so to do that, every time we change row or we change color, we are going to record where we've been. Okay, so let's do that. So this is where I start at hydrogen. It takes 2 steps to get across, and now I'm changing color, or row, actually, I'm changing row. I'm going to write down where I've been. So I'm in the first row, I'm in the S block, and it took me 2 steps. So I'm going to write 1s2. Okay, now I'm changing the row, so I'm going to go into the second row. This is the S block again, and it takes 2 steps to get out of the S block, and I'm going to change color, so I need to write that down. So that's going to be 2s2. Now, jump across. I'm in the second row still, so still in that second row. I'm now in the P block, and it takes 6 steps to get across the P block. 1, 2, 3, 4, 5, 6. So I'm going to record that as 2p6. Now I'm changing row. I'm also changing color. That is the S block, third row, with 2 steps. So 3s2. All right. Now I need to get to sulfur, and sulfur is in the P block, and it's in the third row. So how many steps does it take? Well, you count all of the steps, including the one that it's in. So that's 1, 2, 3, 4 steps. It was in the third row P block, so that's 3p4. And that's my electron configuration for sulfur. Let's try a couple more. We want to do this for titanium now. So locate titanium, put your finger on titanium, okay, see how far you have to go. Remember the starting point is hydrogen. Remember that we write stuff down after we change row or change color. So here's titanium. We're going to go across. That's 1s2. Now we're going to go across the second row. This is the second row, S block, 2 steps. Go across. Now we are in still the second row, P block, 6 steps. Okay, and then across to the third row, S block again, 2 steps. All right, now we are in the third row, P block, 6 steps. Okay, and then fourth row right here, S block again, 2 steps. And now we're in the D block. We are in the fourth row, but the D block is behind by 1. And so instead of writing 4D, since it's n minus 1 and n is the row number, we are going to write 3D. And this is going to be 3D with 2 steps, so 3D2. Okay, so slightly different in that we had to go through the D block and realize that D block is behind by 1. All right, we'll do one more. What is the electron configuration for bromine? We start in hydrogen. This is in the first row, the S block, and it takes 2 steps to get across. Oh, that's bromine. 2 steps to get across. So we write 1s2. Now we're in changing row, S block, 2 steps, so 2s2. Hopping over to the other side. This is still second row, P block, 2p6. Third row, S block, 2 steps. Hop across. Third row, P block, 6 steps, all the way across there. Now we're back to the fourth row, S block, 2 steps. Okay, now we're in the D block, and it's behind by 1. So this would be 3D. It takes 10 steps, 10 boxes here, to get across. So that's 3D10. Now that we're across, we're in the P block. Now it doesn't stay 3, it goes back because P doesn't have anything next to it. It's just P. So it's still fourth row, P block, 5 steps to get to bromine. All right, we can use these electron configurations to draw orbital diagrams. So I'm going to show you how to do that. I'd like you to practice by writing the electron configuration of phosphorus. All right, so it should look like that after you've done that. What you're going to do is you're going to use the shape, that's the letter, or sublevel, and the number of orbitals. Okay, so S's always have 1 or 1 box. P's always have 3 or 3 boxes. D's always have 5 or 5 boxes, and F's have 7. Okay, so we're going to take this, and we're going to say, okay, well, this is a 1s, so S has 1 box. So I'll put a box, label it 1s. Now we have 2 electrons that need to go in there, so 1, 2, up and down. We're going to fill that according to all of the rules from before the Orbital diagram, the lowest energy level first. We're going to do the spins up and down, and then place them in different boxes until we've completed that row all the way up, and then put them down. All right, so then we're now drawing this one, 2s. So S always has 1 box. So it looks like that. We'll label it 2s, and it is important that you do put the labels and put 1 arrow up, 1 arrow down for the 2 electrons that are in it. All right, now we've got 2p. P's have 3 orbitals. So that would be 3 boxes connected together and labeled 2p. Then you put 6 electrons in it. The 3 up first, and then the 3 down. Okay, I know I'm going to fill it, but it's important that you get used to doing them up first. Okay. All right, then we've got this one, which is 3s. S goes back to having 1 box, so this would be 3s. and then you put 2 electrons in it. Now we're at 3p. P has 3 boxes. Okay, so I'm going to draw that there and label it 3p. And I'm going to put 1 electron in each. Notice I didn't try to shove them in 2 boxes. P orbitals, you need to draw them. Even if they're empty, you draw them. And so you just put the number of electrons that go in it. So if it was 3p1, I would have just 1 electron, but I would draw all the boxes for that orbital. All right. If you insist on doing lines, okay, you can do lines. However, I would like you to group them using parentheses. So this is the same thing. You could group the p's, so every time you have a different block, I'd put p's all together by using parentheses here, and then these p's all together. If you have d's, then you put the d's in parentheses. If you have f's, then the f's in parentheses, so that you can see a separation between each one of the orbitals. Okay, so it doesn't look all messy and you can't figure out which one belongs to which. All right, we're going to do this one more time with iron. Here's the electron configuration for iron. 1s gets a box, 2 electrons. 2s gets 1 box, 2 electrons. 2p gets 3 boxes because it's a p, 6 electrons. There you've got the 3s, 2 electrons, 3p, 6 electrons, 4s, 2 electrons, and finally d orbitals, 6 electrons. So remember, we need to draw all of them, and then we're going to figure out how it's filled. So 1, 2, 3, 4, 5, up, 1 down. All right, that took long enough. Hopefully you got the hang of electron configuration and going from electron configuration to orbital diagrams, or vice versa.